Good afternoon, everyone, and thanks so much for joining us today. Um, we can't see you, but we have certainly saw the RSVP list, and we are so thankful to see folks we already know and get to know others and joining us for this webinar today on a topic that we are very interested in and that affects so many different industries. Today's session is focused on PFAS, or you'll also heard it pronounced PFAS, and the food supply industry. We will begin by discussing the various exposure pathways for humans and animals, and then we will talk to you about relevant regulatory action, pending legislation, and imminent litigation, and what your company can be doing now to reduce your risk. My name is Mara Kohara, and I'm the Environmental and Tort Practice Group Leader at Lathrop GPN, and I will be moderating our panel discussion today. Joining me from Lathrop GPM are Allie Cunningham and Matt Walker, and Travis Klein from Geosyntec. Allie leads our firm's PFAS practice. Allie focuses her practice on areas of environmental, toxic tort, and other crisis-related litigation. Her national practice consists of trials, arbitrations, administrative proceedings, mediations, and negotiations to resolve high-stakes, technical, complex disputes involving environmental and tort liability, and at times related insurance coverage disputes. Matt's practice includes all areas of environmental law, including litigation, regulatory compliance, and assistance with corporate transactions. He utilizes his background working for environmental regulatory agencies to advise a wide range of clients on environmental matters under federal and state law and in judicial and administrative forums. Matt also focuses on monitoring state and federal investigation and regulation of PFAS and helps businesses develop strategies to adapt to regulatory developments. Matt is the editor of our firm's PFAS blog. Finally, we are so lucky to have Travis Klein, a senior principal toxicologist from Geosyntec, with us today. Travis is a board-certified environmental toxicologist with more than 25 years of experience focused on human health risk assessment and applied toxicology. Travis is actively engaged in emerging constituent issues and leading characterization efforts in developing positions for negotiations with the administrative authorities at multiple PFAS sites with national significance. He frequently speaks on various PFAS or PFAS topics. I'll now turn it over to Travis, who will get us started today.
Great, thanks, Mara. I assume everyone has heard this before. PFAS are ubiquitous in our society and environment. Their uses and incorporation into consumer products are legion, including weather-resistant apparel, carpeting, paper coatings, dental floss, shampoo, cosmetics. They're everywhere. These compounds are in your blood, they're in my blood, they're probably higher in my blood than yours. We can talk about a lifetime of ski racing and ski wax after this if there's time. My favorite quote, the only place we don't find PFAS is where we aren't looking. We're presuming that all of you have more than a passing familiarity with PFAS, so I'm not going to spend too much time on the 101 stuff. Suffice to say, there are 7,000 plus versions of these compounds in commerce, manufactured since the 1940s. PFAS do not occur naturally. They incorporate the carbon-fluorine bond, which is the strongest in nature. So these compounds are incredibly stable and resistant to both biotic or abiotic degradation. And they're water and oil repellent. And they're bioaccumulative, meaning they build up in our systems as we are continuously exposed. And unlike some of our more recent organic chemistry challenges, such as the PCBs, they're both bioaccumulative and incredibly mobile in groundwater. EPA has not yet promulgated a Safe Drinking Water Act mediated maximum contaminant level, the national standards for drinking water, for any PFAS compound. And while PFAS are perhaps most commonly associated with aqueous film forming foams for fire response, that's not the primary basis for our daily exposure. PFAS compounds are again widely used throughout industry, whether petrochem to electronics, and our focus here in the US seems laser fixed on drinking water, but the single greatest exposure attributable to the general population is probably diet. That's food preparation and packaging. And I wanted to start with these pictures to remind us how much we have yet to learn about responsible use of chemistry available to us in the marketplace. The image on the left is of a fundraiser to benefit disabled children at Camp Shorefoot in Pennsylvania called the Kite Festival, and organized by the Rotary Club of Warminster, Pennsylvania, who invited the local fire department in to spray up a big pot of AFFF for the kids to romp around in. And the rightmost image here is of Cape Canaveral Family Fun Day. Same thing, big bowl of PFAS for the kids. Next slide, please. Uh-oh. My thing has frozen here. I'm sorry. As you've no doubt heard in previous webinars, these compounds have significant bioaccumulative potential. And in target communities, those communities located adjacent to PFAS production facilities or high volume use along the product supply chain, we see blood serum levels that are more than 100 times greater than the drinking water concentrations these people are exposed to. But for the general population, that's you and me, our focus remains on drinking water, when, in point of fact, our daily dose to a compound like PFOS is driven by food preparation and packaging to the tune of about 80% of your daily dose, with drinking water only contributing about 15%. PFOA follows the same basic paradigm. Again, food preparation and packaging drives your daily dose about 60%, but 25% comes from inhalation of particles that have dissociated from consumer products in your home or your office, and drinking water bringing up the rear at about 15%. Next slide, please. Okay, so before I got started on a large risk evaluation last year, I developed a case study to try and understand which complete exposure pathways were actually driving exposure for at-risk communities. To do this, I looked at PFOA exposures associated with a sensitive subpopulation, what we used to call children, in a community adjacent to a large production facility, and evaluated total intake by pathway, and the results were surprising to me, at least at the time. The number one most significant contributor to PFAS intake was ingestion of homegrown fruits and vegetables. But on closer inspection of the data, I've added an asterisk. It seems PFOA was detected in only 2 of 103 fruit and vegetable samples collected from this community. They were both in green beans, and the authors used the maximum detected concentration as the de facto exposure point concentration to evaluate the sum total of a child's fruit and vegetable intake over the course of a given day. So I see this number as at least an order of magnitude overestimate, if not 2. So normally I'd say, let's push produce out of the way. The next most significant intake was associated with ingestion of recreationally caught fish. But again, on closer scrutiny of the data, I have to add another asterisk. It seems that the data that describe these fish tissue concentrations were collected about 6 to 7 years before the remainder of the data that underpins the rest of this study. And in that intervening period, the facility implemented some rather significant stack emissions controls and recorded a 10-fold reduction in surface water concentrations. And we would have expected a correlated reduction in fish tissue concentration. So again, I see the fish tissue or this intake number as at least an order of magnitude overestimate. And so certain phenomena do seem to be driving or inflating some of the ingestion pathways, and it's important to take a close look at the data. And usually here I would move to discuss drinking water and inhalation exposures, but let's pause and look at ingestion pathways aside from drinking water. Next slide, please. Okay, so ag products. The FDA studied milk samples from a dairy farm in New Mexico located adjacent to an Air Force base where AFFF releases had been documented, and the farm's groundwater and silage had significant concentrations with PFAS content in water around 2,500 parts per trillion, more than 35 times greater than the current cumulative PFAS health advisory in drinking water. And milk samples from this farm indicated PFAS levels of 5,000 parts per trillion, greater than an acceptable level based on extrapolation from EPA's drinking water health advisory, and consequently all milk from this farm was discarded. And it's not quite as simple as securing a new water source, at least in the short term. These compounds have long residency times in animals. PFOS has a half-life in humans approaching 9 years. And although residency times in cows is quite a bit faster, it's still lengthy. It takes about a year and a half for a cow to clear PFAS from its system after just 30 days of exposure. And one of the potential exposure pathways contributing to human body burdens of PFAS is the ingestion of home or farm-raised eggs, where laying hens ingest water, feed, or soil contaminated with PFAS. In a key study from Australia that considered 1,300 eggs, we found that the amount of PFAS in the edible part of the egg was proportional to the amount and concentration of PFAS in the hen's drinking water. PFAS compounds are primarily detected in the yolk of the egg, with significantly lower concentrations in the white. And so eggs are laid daily, and the amount of PFOS transferred to an egg was roughly equal to the amount of PFOS ingested by a chicken, chiefly through drinking water, on a daily basis. Other PFAS exhibit lower rates of transfer, running the gamut from 1 to about 70%, and PFOA comes in around 45% efficiency for transfer. Importantly, the time required for PFAS content in eggs to drop to below laboratory reporting levels is at least 100 days after exposure ceases. And I think laying hens are only in production for about 2 years. Okay, let's move on to produce. A 2020 study published in Environmental Science and Technology, which was authored in part by 2 of Geosyntec's lead PFAS researchers, indicates that based on produce ingestion, young children ages 1 to 2 years are the most highly exposed, chiefly through a ratio of body weight to intake, with a risk-based irrigation water target of 38 nanograms per liter for PFOA and 140 nanograms per liter for PFOS. And this suggests that EPA's target health advisory level of 70 nanograms per liter in drinking water may not be sufficiently protective of produce for home ingestion, confirming our contention that water to crop transfer can be an important exposure pathway for certain communities with impacted groundwater. As a bit of a comfort, we haven't actually seen much of this from a pragmatic standpoint in site empirical data, though, and we'll talk about that in a second. FDA also tested for 16 PFAS target compounds in produce like lettuce, collard greens, cabbage, kale, sold at farmers markets in a community surrounding a production facility. And the highest recorded sample content was 1,200 parts per trillion, which is really quite high. But because of how pervasive PFAS are in the environment, including land farming of biosolids heavily laden with PFAS from consumer waste streams, there are many, many uncertainties associated with these results. It's relevant to point out that longer chain PFAS like PFOA and PFOS exhibit greater uptake into the leafy portions of plants, while the shorter chain compounds, C6 and smaller, show greater propensity to accumulate in fruit like tomatoes. It's important, I think, to reiterate here that FDA's conclusion about PFAS concentrations in produce samples from this study fail to indicate a human health concern from ingestion of homegrown or store-bought produce. So it's almost Mother's Day. Do what your mother says and eat your veggies. Next slide, please. Okay, on to packaging. So based on their heat, grease, and stain and water resistance, PFAS became popular for myriad applications back in the 1940s. And it wasn't until 2016, though, that FDA revoked what are called the food contact notifications, or FCNs, to remove long-chain PFAS, like PFOA, from food packaging. PFAS are common in consumer product packaging, including, and probably especially for food, including paper-to-go boxes and sandwich wrappers from entities widely regarded as forward-thinking and consumer safety-focused, like Whole Foods. Washington State became the first to ban PFAS in food packaging, initially targeting microwave popcorn bags and fast food wrappers, and soon thereafter San Francisco banned PFAS content in single-use food containers, utensils, napkins, etc. Maine has also put legislation into place to phase out PFAS in food packaging by January 1st of 2022, and New York recently signed legislation to begin banning the use of PFAS in food packaging to take effect at the end of 2022. federal legislation to ban PFAS in food packaging has already been introduced to the US House of Representatives. There are 15 PFAS food contact notifications approved for use in packaging or serving held by 4 manufacturers here in the US. These include 11 PFAS compounds, but the predominant compound is probably 6,2-FTOH, a 6-carbon chain length fluorotelmer with an alcohol group. Currently considered to have significantly lessened capacity to elicit adverse health effects in humans than predecessor compounds, 6,2-FTOH does exhibit biopersistence in rodents and has begun to show heightened levels of associated toxicity compared to other short-chain PFAS compounds. In July of 2020, 3 of these manufacturers voluntarily agreed to a 3-year phase out of their sales beginning this January 2021. After the 3-year period, it's expected to take approximately 18 months to exhaust remaining stock and exposure, consequently, in the marketplace. Interestingly, the 4th manufacturer reported that it had already stopped sales of 6,2-FTOH products in the US market, indicating that viable alternatives are available now and driving questions about an agreement for this change delayed for the next 4+ years. Also, this doesn't affect imported food or packaging, so your exposure will continue on that front. Notably, and because I love the occasional McGriddle, on February 10th of 2021, McDonald's, which is the world's largest fast food retailer, announced they would phase out PFAS from their guest packaging by 2025. And McDonald's actually eliminated long-chain PFAS, notably PFOA, from their guest packaging back in 2008, but implemented what we call a regrettable substitution, something we tried to avoid in product development. Next slide, please. Okay, on to food here, our focus. The FDA is responsible for authorizing use of chemicals in food contact substances like packaging, cookware, food processing, et cetera, through the Food Contact Notification or FCN program. Certain PFAS are currently authorized for application based on their non-stick and repellent properties. Whether these compounds can dissociate from products and contaminate food depends on chemical-specific characteristics. The PFAS used in non-stick cookware coatings, for instance, do not migrate to food. However, PFAS commonly applied to paper food packaging clearly does. To assess dietary exposure to PFAS, in 2017, FDA researchers analyzed foods originally collected as part of the FDA's fiscal year 2018 Total Diet Study, or TDS, and the results are shown here on this slide. TDS foods were purchased at grocery stores in the mid-Atlantic region of the US and represent the broad range of foods the average US consumer might eat. These results, though, they don't tell the whole story. You can see detections in meat and fish were rampant, all showing levels exceeding EPA warning levels based on agency promulgated oral reference doses, and nearly half the meat samples had quantifiable levels of PFOS, the highest in fish, in tilapia. Interestingly enough and unexplained, the only major meat product line not reported was pork, and that's a little odd. There were many other questions, though, related to this study, but let's get to the heart of the matter. Chocolate cake shows almost 18,000 parts per trillion, but the results are based on an unexpected PFAS variant, perfluoro N-pantenoic acid, or PFPEA. This outcome was the result of 3 cake samples being composited, and people monitoring the study suggested that if only one of the cakes was contaminated, that could approach content of 50,000 parts per trillion. Originally, they theorized that content was related to PFAS coating mixing implements or containers with non-stick or grease coatings, but PFPEA is not approved for use by the FDA, so it really shouldn't be there if we think it's part of the process or packaging related. So could it be part of the water they used? FDA conducted an update with revised analytical methods in October of 2018, and on reanalysis, only 2 of the samples exhibited detectable PFAS content, with results owing mostly to an enhanced and updated analytical sensitivity and repeated testing. The 2 detections were both in fish, in tilapia, and neither, though, at a level indicative of the potential to elicit an adverse health effect in humans. In addition, and of primary interest to everyone everywhere, the updated results for both chocolate cake and chocolate milk indicate that chocolate produces false positives in the original test method, and on reanalysis, both food products are reported not to have detectable PFAS content. I take this as a reminder to view single line of evidence-based arguments or positions with a healthy degree of skepticism. Hooray for chocolate. Bottled water. Right, samples of domestic and imported flat and carbonated bottled water were purchased from retail locations in Washington, D.C. by FDA in 2016, and none of the 30 samples analyzed had detectable levels of PFAS. Microplastics, on the other hand, is quite another topic. The European Food Safety Authority recently estimated that fish and other seafood account for up to 85% of adult dietary exposure, which should raise some eyebrows. While we do see that biouptake in fish occurs at higher rates than it does in produce, it doesn't approach drinking water inputs for target populations and communities. And as noted previously, the highest detections in the FDA food groups did occur in fish, specifically in tilapia, but fish ingestion rates vary quite dramatically across the US by geographic area and society. And my message to you is this: fish is good for you. Just moderate your intake of the organisms highest on the food chain and recognize that your concerns are related to other compounds like mercury or PCB, with the relative impact of PFAS being very, very low. And I'm discounting Inuit men from Greenland, whalers from the Faroe Islands, and fishery employees in China, by the way. Next slide, please. Okay, we're almost done. So it's not just food, though. Myriad consumer products contribute to PFAS exposure. And since 2020, EPA has been embroiled in a study to understand the pervasive use of fluorinated HDPE containers, where we see PFAS ending up in a variety of products. Now, you're not going to drink a mosquito repellent, and if you did, you'd have bigger issues than the PFAS content. But we do see that PFAS are being liberated from containers and into consumer products across the spectrum. Possible it's related to recycled material content as well, though. And from an aggregated cumulative perspective, in total, exposures are definitely worthy of additional scrutiny and study. There's coordinated activity and review being advanced by the EPA, the FDA, the Department of Agriculture, the American Chemistry Council, HCPA, and others, including many state agencies across the US, not waiting for agreement at the federal level about what to do. I think indisputably PFAS are a national priority, but our understanding is evolving, clarifying how to test for these compounds, understanding the toxicological ramifications and health effect, quantifying predominant drivers of exposure. We need to understand the sum total of human exposure, not just drinking water, not just food, not just dust in your home or office. And I'm all for better living through chemistry, and refinement of understanding is part and parcel of product development, mitigating risk while trying to retain as much functionality as we can. Having said that, food content seems to be driven by coated packaging, and PFAS-free packaging alternatives are widely available now and in current use. And retailers have the capacity to eliminate that point of exposure for us today. And I don't think the decision needs to wait 4 or 5 more years. I think that's it for me. Thanks for your time.
Travis, thank you so much. That was certainly fascinating and eye-opening, and we can all breathe a sigh of relief that we can eat chocolate cake. So thank you for letting us know that. I'm gonna now turn it over to my colleagues, Ali and Matt, who are gonna talk about the legal and regulatory developments going on in this area. And I'll first start with Ali Cunningham.
Thanks, Mara. I appreciate it. We can go to the next slide, Abby. So I really appreciate Travis setting up all the kind of broader scientific issues. And as Mara indicated, Matt and I are going to jump into sort of the legal and regulatory developments. And Travis really touched on a lot of this, but why are we here today talking about PFAS in food and handling? And to the concluding remarks that Travis just made, a big source of PFAS contamination and ingestion right now is coming from PFAS food packaging. I think that's a little bit of an underrated topic that needs a little more discussion in the national context. But you can also see PFAS impacts through ingredients, through both contaminated produce, which, Travis did an excellent job of walking us through the, water to vegetable intake ratios, and, in your meat and herd supplies. We'll talk a little bit about how that gets into the food chain and the food supply, but that we'll also leave that to experts like Travis to dive into more in more detail on another day. But, as Travis indicated, PFAS is in your baking and cooking utensils, it's in your food packaging, it's in your water sources, which ultimately goes to both your produce and your animal supply. And we'll talk a little bit more about this. Matt will touch on this later, but biosolids that are land applied for fertilizer are a big source of food contamination, PFAS food contamination. And then, depending on what kind of operation you have, if you have a large amount of real property, real estate, a large animal herd operation, you could be dealing with historic PFAS contamination on your property. So that's kind of an introduction on why we're here today and why we're talking about this. And with that, I'll dive into the next slide. So Travis touched on this as well. I mean, PFAS has been around since the 1930s, 1940s. So why are we just now starting to talk about it? Why are we thinking about it in our food supply? There's a couple of reasons. I mean, one is people just care more about what's in their food. Where food is more heavily scrutinized than ever before. People are looking for organic, non-GMO. They want to know what's in their food. But another reason is the laboratory testing is just starting to catch up with the kind of PFAS measuring capabilities. So, you heard a couple of times there where in Travis's presentation, something was measured in 2017, but upon further investigation, there was a revised analysis in 2019. Or, we saw it in 2016 and 2019 with bottled water. You can see it in a couple of different aspects of the food industry, but suffice it to say, the testing is just catching up. And it's not always, all testing is not created equal, I always say. So some of the testing is more reliable than others. Some of the newer testing in the last few years can get to even lower detection limits than we've ever seen before. And so it's giving us new information that we just never had about what's in our food, what's in our food packaging as far as PFAS goes. The other issues are kind of intertwined. There are at least claims that health effects can occur from PFAS exposure at very low levels. That ties into a lot of the health advisories that Travis mentioned. The EPA health advisories are extremely, extremely low. Travis mentioned that 70 nanograms per liter level, that equates to 70 parts per trillion. I always like to use the example that that's the equivalent of 3 grains of rice in an Olympic-sized swimming pool. So we're looking at a very minute amount of PFAS causing a very large problem, potentially. This is a great little infographic we always have on here about the state of Indiana. And so the equivalent of 70 parts per trillion would be essentially 70 kitchen floor tiles within the entire state of Indiana. So again, those are the advisory levels that have been issued by the EPA that are extrapolated for some of these consumer product issues. And it's really difficult to meet these thresholds. It's a very minute amount of PFAS that can really trigger an issue. And the last point I'll touch on before I turn it over to Matt is, the other issue that's very challenging with PFAS is it's being regulated differently in almost every state in the US. So if you look at states like Michigan, they're very progressive and they have very, far-reaching PFAS regulations. If you look at a state like Missouri, for example, we don't have as many or any state PFAS regulations in place. There's a lot of discussion at the federal level. It's been on a very fast track, I would say, under the Biden administration. We could talk about that all day as well. But the kind of broad headline that you need to understand is if you have a multi-state operation, you may have different compliance points in each state that you operate in. And that can be very, very challenging to deal with, along with, what's coming down the pike on the federal front. So adapting to that, complying with that is a big challenge for a lot of manufacturers, but especially those in the food supply industry.
Thanks, Allie. And before we talk to Matt about how he's going to dive deeper into this and go over the state and federal regulatory action, we first need to give you the PFAS CLE code. So we'll put that slide up next. For those of you that are licensed in certain states that need the code, you can see that. And then if you or one of your colleagues miss this, just send us a message and we can send it to you. Leave it up for another couple seconds and then we'll go on to Matt. Thanks.
Great. Thank you, everyone. So I think it makes sense to start with water. I think everyone on this presentation realizes how important adequate fresh water is, both from a quantity and quality standpoint in food production, whether it's on the primary production side with irrigation, watering, or in processing as an ingredient or a hygiene aid. Clean water is critical. And in particular, it makes sense to start with the UCMR3 testing that occurred between 2013 and 2015. And the UCMR testing, that stands for the Unregulated Monitoring Contaminant Rule. It's a testing program that's administered by the EPA under the authority of the Safe Drinking Water Act. And what it's intended to do is test for potential contaminants in public water systems, generally large public water systems that are not yet subject to the primary drinking water standards. In 2013, EPA began testing for PFAS, 6 different PFAS. And what they discovered was rather shocking. And I think this is what really kicked off a lot of the public awareness and public scrutiny over PFAS. PFOS was found in just under 1% of public water systems, exceeding EPA's 70 parts per trillion standard, PFOA in 0.3% of systems, and combined, this resulted in over 6 million Americans consuming water from public water systems that exceeded EPA's health advisory level. The UCMR4 testing, again, this occurs about every 5 years. The UCMR4 testing doesn't contain any type of PFAS testing, but the UCMR5 testing, which is scheduled between 2023 and 2025, that will include 29 different PFAS and lithium, but 29 different PFAS. And that was actually mandated by the 2020 National Defense Authorization Act. EPA was required in the UCMR5 testing to test for any PFAS that it has a validated sampling methodology for, and that's 29 different PFAS. So, I raise this because it has implications for the food processing and food production industry in a couple of different ways. One, it's a good resource to have and be able to understand where sources of PFAS impacts are coming from. This map, this shows the hydrological units. This isn't exactly the spatial extent of PFAS contamination, but it shows the breadth of PFAS impacts across the United States. The second important part of this is that, typically you can trust municipal water to meet water quality standards and that it's healthy for potable consumption. This indicated that despite our testing and our understanding of our water quality, there still may be issues that we have not yet identified, and it's important to keep up with these regulatory developments and testing. And the third point is that it ultimately does lead to developments, regulatory development. So the data is not just for public consumption, but it also goes to the development of drinking water standards, which is exactly what happened in this case. You can go to the next slide. So originally EPA had only established a non-enforceable, non-regulatory standard in 2016 at 70 parts per trillion. It doesn't apply to food containing PFAS, but it applied only to PFOA, PFOS, or the combined level between the two. But as a result of the UCMR3 testing, EPA issued a final regulatory determination deciding that yes, PFAS, primary drinking water standards for PFOA and PFOS are necessary in light of the testing results. And given the regulatory process, we don't expect to see that for several years, and there hasn't been exactly an indication that at what level they will set the drinking water standards. I mean, some might expect that it will be at the 70 parts per trillion that EPA has been using based on their scientific research, but that remains uncertain. You can go to the next slide. Where EPA has been a little slow to regulate the potential impacts of PFAS in drinking water, certainly the states have been kind of picking up the slack, but as you might expect, it's taken a patchwork approach. And as Ali mentioned, this can be incredibly challenging for businesses that have states or operations in various states when you're complying with regulations and drinking water standards that not only utilize different standards. Some, for example, adopted EPA's 70 parts per trillion standard. Some, as you'll see on the next slide, adopt much lower, much more stringent standards, but they vary between the type of media that is impacted, as well as the type of PFAS that they might test for. So this creates a challenge from both a business and a regulatory side, trying to keep track of the variation among the states in the absence of a clear federal standard. And you can go to the next slide. As I mentioned, there's several states that presently have enforceable drinking water or other PFAS-related water standards. Some are currently proposing drinking water standards for a variety of PFAS. And I always caveat this slide too. I made this image with the PFAS standards probably a couple of months ago, but already it's probably outdated. The regulatory environment among the states in developing PFAS standards is rapidly changing. You can go to the next slide. Other potential or other ways that we're seeing PFAS regulated, particularly in the food industry, I think Travis had touched on this earlier. EPA had recently exercised its authority to issue a subpoena under TSCA, the Toxic Substances Control Act, to investigate whether or not fluorinated HDPE containers might be leaching into pesticides. And they found that significant levels were in fact leaching into the pesticides, but EPA made a point to note that none of the pesticide that it was leaching into was used in the agricultural context. It was used primarily in cemeteries and golf courses, which still isn't great, but it wasn't used in food production. And as a result of that, there's been some interagency coordination where now they're investigating with the FDA and the USDA to determine what other type of agricultural products might be impacted with leaching fluorinated containers, and then also is offering recommendations on alternatives to fluorinated HDPE containers. Another area that has certainly been of concern is land application of biosolids. Presently, there's no PFAS standards, numeric or best management practice for land application of biosolids under the biosolids regulations. But it has certainly been a point of investigation for those that have ongoing and active biosolid and land application processes. I don't expect that many of the people listening to this presentation are land applying high PFAS concentrated biosolids, but the concern is if you have been land applying biosolids, maybe from a municipal source that accepts a lot of industrial wastewater. And what they're finding is that the short train compounds tend to bypass the publicly owned treatment works screening process, whereas the longer chain compounds get accumulated in the sludge, which is being land applied. EPA is conducting a risk assessment for biosolids more generally, but it's also going to incorporate an analysis of PFAS. We probably won't see that for several years. It could ultimately lead to development of numerical standards for PFAS or other best management practices. EPA is also currently developing a testing methodology for PFAS and biosolids that's currently being developed. But we're seeing this concern actively played out. At least in one case in Maine, there was an issue where a farm that was raising cattle and growing hay had been land applying municipal biosolids. And that was, during a state investigation, that was identified to be a potential source of PFAS that had bioaccumulated in hay, which was fed to cattle, and then resultingly showed up in the milk production. So these are legitimate concerns that we're seeing actively played out. You can go to the next slide. On the effluent side of things in the wastewater, EPA has taken some action, but we expect that this type of regulatory oversight to increase over the next couple of years. Recently, there's been two related developments. First, EPA issued an advance notice of public rulemaking in which they were requesting information that they would use to develop effluent limitation guidelines for PFAS manufacturers. This is specifically the organic, chemical, plastics, and synthetic fibers category. I don't anticipate that many businesses that fall within that category are probably within this audience, but it's important to note that as part of that advance notice, they also requested information on formulators, which are those businesses that use and manufacture PFAS in consumer goods and or for application in consumer goods. So we expect to see that is kind of the first step to developing effluent limitation guidelines for dischargers within that category. EPA also released guidance for federally issued permits in which they recommended that permit writers who are writing permits for that the federal government issues, which includes tribes and a handful of states, that they begin to include PFAS monitoring requirements, as well as other best management practices to address PFAS. Certainly from the guidance, it seems that this approach will be adopted by state permit writers. And even if you are not a direct user of PFAS, part of the problem is that PFAS at such low levels can accumulate from a variety of sources in your operations, whether it's food contact materials, packaging, and other processing. And you could have low levels that accumulate into a noticeable discharge of PFAS. And finally, as another part of the National Defense Authorization Act, which I mentioned earlier, that added 172 PFAS to the toxic release inventory reporting beginning this year in July 1st, 2021. And I raise this not because I expect that many of you might be subject to the reporting requirements, but because this is going to considerably increase public scrutiny over users and releases of PFAS. When these results are ultimately published by EPA, probably in early 2022, I think there is going to be an intense public scrutiny over those facilities that are reporting PFAS releases. And if you're someone that has been impacted by PFAS and are looking for a way to identify potential sources, I think this is going to be an important tool. You can go to the next slide. Travis had mentioned earlier about the voluntary phase out of PFAS, of certain PFAS in short chain compounds. But I will note, and while long chain PFAS have largely been phased out of food packaging, I will note that there are still several uses of PFAS applications in food packaging, gaskets, nonstick cookware, all which EPA is presently approving. So despite some of these voluntary efforts and some of the more regulatory efforts over the longer chain compounds, there's still plenty of sources where PFAS could potentially be present in food packaging that are still currently approved by the FDA. One program that I wanted to note in general, or in particular rather, is the National Residue Program. And this is a program that's administered by the USDA's Food Safety and Inspection Service. And kind of similar to the UCMR testing, it's designed, they develop a sampling plan that's designed to gather data and information about the prevalence of PFAS in our food. In 2020, it involved testing beef samples for 16 types of PFAS. And in 2021, they plan to expand testing of PFAS to pork, chicken, and catfish. And what's interesting about this is that this PFAS testing program was developed in coordination with the USDA, the FDA, and the EPA. And I think this goes to show and highlight the increased federal scrutiny over PFAS throughout our food systems and throughout the environment, but also the heightened federal coordination that these agencies are getting together. They're sharing information, and because they recognize just how pervasive of a problem this is. You can go to the next slide, please. Some pending federal legislation that you should be aware of. First, the PFAS Action Act of 2021. This is notable for many reasons, in particular that it would designate both PFOS and PFOA as hazardous substances under CERCLA within 1 year. But from a food perspective, it would also create a voluntary labeling system and allow the administrator to revise some of the safer choice standards, which are used to, it's a voluntary program for labeling for safer choice products that, and this would allow it would allow the administrator to mandate that those seeking that label not use any PFAS in their coatings. Another important piece of federal legislation is the Keep Food Containers Safe from PFAS Act, which you can probably guess from the title. It's designed to keep PFAS food coatings out of our food systems. Notably, it would give the FDA the authority to ban the use of any type of PFAS in food containers and cookware by 2022. You can go to the next slide, please. Finally, Travis had touched on a few of these as well, but this just highlights again the disparity between states in their regulation and how they're approaching regulation of PFAS in food packaging. New York, Maine, and Washington have all largely banned the use of PFAS in food packaging. California, of course, they have their Prop 65 law, and in 2017, they required clear and reasonable warnings for products that may contain PFOA and PFOS, and actually just recently formally designated PFOA as a substance that is known to cause cancer or reproductive harm in 2021. Other states have proposed additional legislation to address PFAS in food packaging. Again, it's a rapidly increasing regulatory environment for by the states in the absence of a clear federal oversight, and is going to pose a challenge for states that, or for businesses that with multi-state operations that need to comply with a patchwork of state legislation.
Thanks, Matt. And we had a question in the chat that might be a good time to see if any of our panelists can answer. It was a good question about the fact that there's so many containers containing PFAS, and the regulation is not really there yet. So, and the sufficient data on public health impacts. Do you have any sense of whether there are prospects for there being implementation by the federal government of regulations rather than on the state side, similar to like PCBs and TCDDs? And if not, we can certainly respond back, but I know this goes on with the Biden conversation, I think, Allie.
Yeah, I can jump in on that. I mean, I think it's hard. I always joke with my clients, I wish I had a crystal ball. We get the same question in the environmental context too, of how soon do you think PFAS will be regulated as a hazardous substance or a hazardous waste? And will it be all PFAS, or will it only be PFOA or PFOS? And I don't know. I don't know the answer. I think we're seeing a lot of action from the Biden administration in a very quick way. Matt touched on the PFAS Action Act, which I think is putting a lot of pressure on the government. We're seeing a lot of activity from the EPA, unannounced, proposed rulemaking, et cetera, et cetera. But as far as widespread federal regulation, it's an unknown. Particularly from the FDA, they've been notably quiet on this too. I think that's one thing that we kind of have emphasized throughout this presentation is, you're seeing a lot of EPA action, not as much FDA action. And how does that interplay, and what will be the result?
It's sort of my misstatement in the question. I mean, the key term is regulating PFAS as a chemical class. Does that still keep with your with your response?
The idea, you just generally see so much more regulation of PFOA and PFOS because they're the two most common PFAS compounds. But whether the government and how we'll choose to regulate it as a class or regulate specific compounds, I think really remains to be seen.
Yeah, if there's one fundamental tenet in toxicology, it's dose makes the poison, right? And until the biggest, I think, issue holding back progression on this front is our understanding of the toxicological implications. We have 7,000 plus compounds, and we're never ever going to be able to go through all the required testing to see each compound added to US EPA's integrated risk information system, for instance. So we're going to have to come to grips with a system to assign relative toxicity similar to the way in which we manage the dioxin-like PCBs or dioxin-like congeners, or the carcinogenic pHs, for instance. If there's a way to group PFAS into large groups based on, let's say, chemical size or functional group, and assign a toxicity characteristic there, then you can start to organize a program. But until there's agreement on, and there isn't even agreement on what the toxicological ramifications are that should underpin things like drinking water standards. If you look across the states, everyone picks a different basis. They pick a different seminal study. They pick a different effect to be protected against, whether it's ossification of phalanges, that's like fingers, or it's delayed mammary gland development, or it's immunosuppression. There's no agreement whatsoever. So it really is very much like the Wild West that's playing out mostly on the state playing field at this point.
A follow-up question to this is, and we may or may not be able to answer it at this point, but why aren't manufacturers mandated to provide sufficient health data to prove their products are safe? Do we know that just yet, Travis? Have any thoughts?
Yeah, I think that for the most part, they do the best that they can, and there certainly are requirements before these products hit the marketplace. It's just that the effects we see occur, typically that testing is like gross effect, like an understanding of, what constitutes an LC50 or an acute health effect. But it's very different when we set those standards. We're talking about very high concentrations being tested in animals over short periods of time. And that's not how people are exposed. People are exposed to very, very, very low concentrations for very long periods of time, as well as the opportunity for synergism or sort of cumulative effect, where those studies are predicated on single compound exposures. But when we're talking about epidemiologic studies in humans, that's populations or communities exposed to many, many, many of these compounds concurrently. It's really quite tricky.
We have a couple more questions, but we'll go on, Allie, with your next part because we're running out of time, but we'll make sure we respond to some of these really good questions in the chat. And Allie's now going to talk about some things businesses can voluntarily do to reduce PFAS in their food supply and what litigation might look like around the corner related to PFAS.
Thanks, Mara. And I'll try to go through this as quickly as possible so we have some time to answer some questions. So as we've kind of all explored both through the Q&A and through Matt's presentation, PFAS regulation is all over the map, no pun intended. So there's all kinds of crazy, differentiation between state regulation, federal regulation, EPA, FDA, et cetera, et cetera. A lot of companies have taken that lack of clear regulation upon themselves to just voluntarily enter into some sort of, self-imposed regulation to try to avoid PFAS liabilities down the road. So a big one came out last week. Wendy's is going to start phasing out PFAS in their food packaging. Big steps, because as Travis touched on earlier, food packaging is one of the biggest, kind of issues that we face. McDonald's has done the same thing, and now we've seen it with Amazon Kitchen, which we'll talk about that a little bit more in a second, and in certain grocery store chains as well. So we'll jump to the next slide, Abby. One of the really great examples of kind of self-imposed regulation, or that, begging for finality and clarity from the government, is through the International Bottled Water Association. They've actually approached the FDA twice, asking them to regulate bottled water and PFAS levels. and the FDA has refused twice. There's a difference in PFAS or in testing mechanisms, which I won't get into here. The FDA did some testing, and for 30 different bottled waters, they found no evidence of PFAS. When Consumer Reports did their own investigation, they found PFAS in 43 out of 47 bottled waters. So it depends on, and this gets to kind of Travis's comments just a minute ago, what compounds are you looking at? What's your detection limit? How low are you going? What's considered a concerning level of PFAS that's actually going to have a toxicological effect on your body? Those are all things that really get at this discussion that are still in flux. But the Bottled Water Association is unable to get FDA to jump on that. And so they have made recommendations to their organization of 5 parts per trillion if it's only a single PFAS compound in the water, and 10 parts per trillion if it's more than one PFAS compound. Next slide, please. And I apologize, I'm breezing through these so we can try to get to some of your questions. This is probably not super relevant. At this point, there are several do not eat warnings that have come out in different states. This really pertains to wild game, but it's a good signpost or guidepost of what could come, if you could see further FDA regulation in the future. What's interesting, I think, about this is you're getting these warnings from state environmental regulatory agencies. So, DNR, ADPH, that kind of thing. It's been largely for fish and specific types of fish in specific waterways and streams. But again, this also showcases the issue with, Alabama, Michigan, and Wisconsin are testing their fish and issuing do not eat orders. Does that mean there's not PFAS in my fish in, Iowa? Probably not, but they just haven't taken that step yet. Next slide, please. So notable litigation, the Highland Dairy case is really well known. I guess most everyone who's attending this webinar is probably familiar with it. What I really want to highlight with that case, it was ahead of 5,000 dairy cattle, large dairy operation that was ultimately shut down. They sued 3M for contaminating. It was really an Air Force base, but they sued 3M, the manufacturer, for contaminating the water that their cattle were drinking out of. What's interesting here, I think, is the FDA extrapolated from EPA health guidance what was acceptable and not acceptable for both the for the cattle to be drinking and what they were seeing in the milk and in the beef itself. And so that was a big challenge for the dairy operation to overcome, to know, what is an acceptable level. They got shut down, but it's because the EPA made this extrapolation from health guidance. Whereas, if FDA came out with a clear, bright line rule, it would be much easier to determine your compliance point. The other 3 cases, Amazon, Kroger and Albertsons. Kroger and Albertsons are obviously both national grocery store chains, are a new kind of horizon in PFAS litigation that we haven't seen. All 3 sold products, food packaging products specifically, that were considered compostable. So paper plates, cups, paper straws, napkins, that kind of thing. Ultimately, it was found that the products had PFAS in them, and so they were not compostable. And so class action litigation was filed, which is seeking recovery for the additional price that you paid for a compostable food packaging material. The Amazon case was dropped, but it put enough, fear in Amazon that they've now since phased out PFAS-containing food packaging in their Amazon Kitchen product line. The Kroger and Albertson cases were filed last year, I believe, and are still pending. So I think there's a lot to learn from that. Next slide. Okay, and these are some best management practices. I will touch on these really quickly. I know we're at the hour. Basically, knowledge is power. Figure out, what you know about potential PFAS liabilities in your food stream, potential PFAS in your ingredients, potential PFAS historic use on your property, and what testing information might be available to you. Try to learn what you can about what the different state and federal regulations are. They're changing constantly. As Matt said, we make a graphic and 2 days later, it's no longer relevant or something about it has changed. So trying to keep up to date with information is really the key here, both your own information and what information is available on the toxicological effects of PFAS, the regulation of PFAS, et cetera. One last slide, I think. We've talked about, not all testing is equal on PFAS. These are some points I'll dive into maybe on another presentation another day, but there are things you can do, contractual indemnities, phase 1 investigations, although PFAS wouldn't technically be included, you need to have it added specifically, or insurance discussions that you might want to be having if you think you have a PFAS liability. So I apologize for the super warp speed wrap up.
Thanks, Allie. And there's some good questions. So to the extent people are still staying on, if anyone can, any of our panelists can talk about the ECOS or ECOS white paper on PFAS standards, is a familiar, reliable source for tracking state PFAS rulemaking standards, setting knowledge. Can you comment on whether that is a good source for tracking? Because it seems to be updated periodically. Anyone have knowledge of that on this call?
I don't have particular knowledge about the ECOS white paper, but one reference that I think is generally well respected among the scientific and regulated community alike is the Interstate Technology and Regulatory Council. It's a interdisciplinary group that's generally, there's members from the public side of things as well as the private industry. And I find that their materials are very well done and seem to be generally accepted among those in the reviewing PFAS related things.
Thanks, Matt. And another good question, and we've probably looked at this or don't know exactly yet, but are there other countries that have a more consistent regulatory system in place that the United States could look at as potential model or for to export considerations?
Matt, you can weigh in here. One of the other countries that's facing really significant PFAS issues is Australia, actually. So there's been a lot of tribal litigation in Australia to deal with historic long-term exposure to some of the tribes in Australia, and that's been something interesting to watch, but I don't necessarily perceive that they're handling it any better than we are. The EU is kind of, I think, also just in the very early stages of learning to regulate this compound. I think it goes back to the lack of testing. We can only regulate when we can test, and we haven't been able to test until very recently. So I think it would be interesting to see if there is some sort of like global alliance to look at regulation as a whole, considering how, for instance, ag in particular, we exchange so much food product with China, for example. But I don't know of any other country that I think is really farther down the road than the US.
Thanks, Allie. And then Matt, I know if you could take the MSDS question, that would be great.
Sure. So the question was, how reliable are most MSDS documents on PFAS? I've had several showing PFAS weren't declared in the documents. That's true. It's for most safety data sheets, you are not going to see it labeled PFOA, PFOS, PFAS. Half the time you're going to see safety data sheets that just refer to them generally as a fluoroalkyl substance, and it might not even be direct. It may use some variation of the word fluoro. I think that's really what you should look for. You should also look for specific products that have a reputation for containing PFAS products. The other issue is that sometimes producers just will refer to it as a proprietary ingredient. So you really have no indication of whether or not it's a type of PFAS. That's going to change to some extent now that PFAS have been added to the toxic release inventory. There's now requirements for you to disclose TRI reportable chemicals on safety data sheets. But also, if you're unsure and you have questions, maybe consider reaching out to the manufacturer of that product, or even consider doing testing of the product on your own.
Yeah, I echo that, Matt. But we've seen that in the cosmetics industry too. The MSDS are not reliable, and it creates a real challenge. It can be difficult to get your hands on a proper ingredient list.
We did just get a question, apparently, a few minutes before the webinar. ATSDR released a final toxicology profile. I know that's something we haven't been able to look at yet. So whoever asked that question, if you will contact us separately, we would be more than happy to have a conversation with you about that, unless anyone on our panel is able to comment on that now, as it was just released before we started. And Travis, if you're talking, you're on mute, just FYI.
Sorry. If it's consistent with the draft, it's notable in that the ATSDR minimal risk levels for ingestion, they're intermediate MRLs, meaning that they're protective of exposures that are presumed to last over a year. And the US EPA has promulgated oral reference doses, which are presumed to be protected over exposures of a lifetime. So let's say 70 years. And yet the ATSDR intermediate MRL is an order of magnitude more stringent for both PFOA and PFOS than the US EPA RFDO. And it just harkens back to what we were talking about earlier, that there's no agreement at the federal level between US EPA and ATSDR about which seminal studies to look at and in terms of protecting against what critical effect. And that has just cascaded down to the states. So they are picking and choosing as they see fit.
Great. I think with that, we've pretty much talked about everyone's questions. We really thank everyone for joining us today and look forward to a future webinar, as we know this is constantly changing. And if you do have any other questions, you're welcome to reach out to any of us that were on the panel. Thank you for your time and have a great rest of your week.